Hi, this is the solutions video for the chapter 7 through 9 test on spring chapter 7 through 9 spring of 2013 for stats here. So we have a bunch of hypothesis tests and confidence intervals, and that's pretty much it, each type. So I'm just going to go right to it. This first one here is just a one proportion z-test. So our null hypothesis is that it's supposed to be 6%. The alternative is that it's going to be less than 6%. We calculate our z-score here to see how far away 0.047 is from 6. And it's about a little over 1 standard deviation below average here, which is not very far. And if you look that up in your z-table, it's about 0.1423. And since that is greater than 0.05, we will fail to reject the null, and there's not enough evidence to say that the true proportion is below 6% of no-shows. If I saw errors on here, sometimes it was they forgot the p's, maybe a miscalculation, and sometimes they would say reject or fail to reject or whatever it was, but they forgot to give the reason why. So I would take points off if you didn't put it in context, addresses the original claim. And then the type 1 and type 2 errors here. Type 1 is reject the null, say the proportion is less than 0.06, but it's really not. And the type 2 would be fail to reject the null and say the proportion is 0.06 when it really is not. And then the 95% confidence interval is right here. There's 0.047 plus or minus 1.96 is our multiplier for that confidence interval. There's our standard error. And so we are 95% confident the true proportion is between about 2.5% and 6.8%. And since it says, does the interval contain 6? Well, yeah. So we don't have enough evidence to refute that, because that is, we're 95% confident the true proportion is somewhere in there, and 6 is also in there. So on number 2, this is about manufacturing ball bearings. The null hypothesis is that the average is 30. A lot of people forgot to use the mu here. The average is 30. The alternative is it's less than 30 to see if they're light. And this is using a t-statistic since it's with means. There's our sample mean. What we thought it was supposed to be is 30. And we divide by the standard deviation over the square root of n. And so we get a negative 0.6 as our t-score, which is not very big. And even if we pull up our t-score, and degrees of freedom was what, 16? That's the sample size. 16 minus 1 is 15. So if we look at our t-score, row 15, 0.6 is definitely way over here, which means it puts our p-value above 0.1. So we just say the p-value is obviously is greater than 0.1, which is bigger than our threshold of 0.01, so we will not reject or fail to reject the null hypothesis. Not enough evidence to say that the ball bearings or the average of the ball bearings is light. The type 1 and type 2 errors is to reject and say, yeah, they are light, but you're really wrong. Type 2 would be, say, fail to reject and say, no, they're fine. They weigh 30, but they really are not, would be the type 2 error. The 99% confidence interval, this is the biggest point here. There's a sample mean, but the multiplier, a lot of people used 2.57 or something like that, but we should use our t-table, row 15, so I'll pull it up again. Row 15, and we want the 95% confidence, which is this middle column, row 15, so there it is. Or 99% confidence right there. Far right column, and it's right there. 2.947 is our multiplier, so this should be 2.947, and then standard deviation over the square root of n. So we're 99% confident the true mean ball bearings are somewhere in here. And since 30 is in there, it asks, is 30 in the interval? Yes. Is in manufacturing steering light ball bearings? The answer is no, or we can't prove it anyway. On 3 here, this is a difference in proportions. They actually kind of give you a good hint here that the claim is that the proportion is higher with college-educated over non-college educated. So our null hypothesis is those proportions would be equal. The alternative is that they're different. We calculate our z-score here with the sample proportion. So 53% are satisfied in college-educated, 49.3% with non-college educated, which gives us a z-score of 0.59, not very big. So obviously this p-value of 0.2776 is bigger than 0.05. Fail to reject. There's not significant evidence college-educated adults are more satisfied with their work. The type 1 and type 2 errors, we reject the null. say that the college-educated is a higher proportion, but it's really not. The alternate in the type 2 would be fail to reject the null, say there's no difference, but there really is a difference. In the 95% confidence interval, there's the difference in the two proportions. We're going to use 1.96 since we're using 95% in Z. There is our standard error. So 1.96 times that. So we're 95% confident the true difference in the proportions is between 0.077 and 0.153. And the question is, are they different? You'd say no, because 0 is in there. Number 4 here, this is a difference in means. So our null hypothesis that the two averages are equal in this beats per minute if they exercise and don't. The alternative is that if they don't exercise, they'd have a higher resting heart rate. So we calculate the difference in the two means. We get a t-score of 1.474. And our degrees of freedom is n1 plus n2 minus 2. So 26 degrees of freedom. So if we look at row 26 for 1.474, row 26, 1.4. So it's somewhere in here. So our p-value would be between 5 and 10%, because that's where the test statistic would fall, right in there, somewhere in this area. So it's between 5 and 10%. Since p is greater than 0.05, we will not reject. There is not significant evidence that the heartbeats per minute are different. The errors would be type 1 be reject and say there is a reduction in heartbeat, but there really isn't. If you exercise, the alternate in the type 2 is fail to reject the null and say there is no difference in heartbeat, but there really is. And then a 95% confidence interval. Again, this is the tricky part. 95, some people use 1.96. We need to use 2.056, and that comes from row 26 right here, right there, 2.056. And we calculate that, so we are 95% confident the true difference in the mean heart rates is between -2 and +12. And since 0 is in there, you're going to say no, there's not a difference, because there's a possibility that there is no difference between these populations based on that data. Number 5, last page, 5 and 6 are on the last page. I did not count off for this. This is a dependent or paired data. So we're using the plots from the field here. Our null hypothesis is that the mean difference in the yields would be nothing between the plots. Since they're paired, it's in the same field. The ground should be the same. And the alternative is that the mean of this dependent sample would be greater than 0. So we'd see an increase in yield. I did not count anything wrong there, but you might want to take note for the final on that. We calculate the t-stat. There's the average difference in yield, standard deviation, and sample size. So we get 2.18. And if I make this a one-tailed test, and I look up 2.218 in row 8, if I do that, row 8 is right here, 2.218, gives me between a 2.5% and a 5% chance if it's one-tailed. So that is less than 0.05, so reject the null. There is significant evidence that additive increased yields. Now, if you made this a two-tailed test and you doubled your p-value, then it would be greater than 0.05, and I accepted that as well. But I would encourage you to, that we're definitely seeing that the additive increases yields. It's definitely one-tailed, I believe, but I counted both. Type 1 and type 2 would be reject and say the yields increased with the additive, but they really didn't. Type 2 would be do not reject, so there's no difference with the additive, but there really was. And then the 95% confidence interval, there's the 2.306, which comes from row 8 here. Right there, another 95% right there. And then, so we are 95% confident the true increase in yields is between -0.075 and +3.875 bushels per acre. And so notice when this goes two-tailed, because all confidence intervals are two-tailed, all of a sudden we have 0 in there. So you'd say, no, there's not a difference based on the confidence interval. 0, and I think this is a good problem to illustrate how the difference between one-tail and two-tail can affect your decisions. And the last one is, I think almost everybody missed this one. It says, the researchers found that there was an effect on hearing from loud music, which means there was significant hearing loss. That means the test statistic or the p-value was less than 0.1. The question is, would it have also been rejected at 0.01 or 0.05? The answer is maybe. If it was very significant, like if the test stat was down here, we'd say, yeah, reject it both. If it was in between here, we'd say reject it this one, but not that one. So the answer is maybe, because we don't know where it's at. So that's the answers. There were 62 points, and I curved it 7 points. So I really made it out of 55. So I gave everybody a little over a letter grade curve on this thing. So I hope that helps you get ready for the final or for the test the next semester.